record. Alright. I got 4 problems picked out. Well, not picked out, they come out of the book. And we'll go ahead and do those. And hopefully and these are type questions that'll be on the test. And they may not be too difficult for you. Alright. X cubed plus x over x minus 1. Okay, now before you even start this problem, you need to look at it because you're not going to use partial fractions. Well, Hubert, that's what we're in. Yeah, but we're also looking at the degree of each numerator and denominator. What do you see about this numerator and denominator? Fall back on your algebra. I'm sorry, I heard. You could simplify the top, yeah, but that's not what I want to do. You could factor out an x, but that's really not going to help you because how many denominators do you have? Partial fractions, you normally have what? Multiple denominators. So something's up with this problem. What's up with it? How about you Skype people? Anybody got an idea? I'm sorry, what? Long division, exactly. What do you notice about the degree of the numerator compared to the degree of the denominator? It's greater. Do you remember vertical and horizontal and oblique asymptotes in algebra? Everybody's supposed to shake their head. Well, that's what you look at. You look at the degree. Now, the degrees can be the same and you can still divide. But the problems that we were doing the other day, the numerator was degree less than the denominator. So you got to look at the degree. So go ahead and long divide this and then rewrite it as a integration of long division. Or the, what is it when you, well, the factor, the dividend or whatever. I forgot that divisor dividend stuff. So you're going to rewrite it as the dividend. I think it's the dividend. So let's just go over here and do it this way. X to the 1 minus 1x to the 0 x to the third plus 0x squared plus x to the first, and that's it. Well, plus 0x to the 0. Now, some of y'all, if you haven't had me for algebra, some of y'all might look at that and go, what in the world is he doing? Well, what is the stipulation? There's only one stipulation with long division of polynomials. And what's that stipulation? All y'all don't talk at one time. Okay, I'll just leave and y'all can just read it out of the book. How about that? Each place value must be what? Must be represented. Or you put a blank wherever there's a missing place value. Y'all remember that from algebra? Okay, I got a, okay. So that's why I put in the 0x squared and the 0x to the 0. Because there is your degrees must be in descending order in the long division of polynomials. Hopefully some of this is ringing a bell.
No, not.
All right, how many times will x to the first go into x to the third? X squared times, Hubert. That's right, class. X squared times x to the first is x to the what? Third. X squared times negative x to the 0. What do? Add the what? Add the exponents, and that's going to be negative x what? Negative 1 x squared. And what do you always do with division at this point? I hadn't heard anything. I think I heard a murmur. Thank you. Subtract. That's how you say it, y'all. And when you subtract, what does that make these two? Makes this a negative and this a what? Positive. And what happens to the first term? It always cancels out. And x squared, 0x squared plus 1x squared is 1x squared. And then the x comes down to help out. Okay? How many times will x to the first go into x squared? X to the first times x to the first times x to the first is x squared. X to the first times negative 1x to the 0 is negative x to the what? To the first. Thank you, class. Appreciate the interaction. You always subtract, which will make this a negative, and this a what? Positive. The first term always cancels. And that'll give you x plus x is 2x plus 0x to the 0, or 0x 0. Now how many times will x go into 2x? 2 times. 2 times x is 2x. 2 times negative 2x to the 0 is negative 2. X to the 0, which is 1. Always what? Always subtract. That'll make this a negative. Make this a positive. That goes out. And you have a what remainder? 2 remainder. Oh. Have I used the black marker that big? Y'all supposed to say no. No, I haven't. So tell me how it got that way. Damn Russians. Okay, 2 remainder. Now remember how you wrote your remainders, how you write them. Let's go back to the 3rd grade. 2 will go into 7. How many times? 3 times. 2 times 3 is 6. Minus 1. And you put the remainder over the what? Divisor, or whatever that thing is called. Somebody Google it and look it up. Because I can't remember what it's called. So we got to put, so our answer now is what? This, Hubert, that's right, x squared plus x plus 2 plus what? 2 over x minus 1. How many of y'all remembered that from algebra? Oh, y'all are lying. Annabelle, you remember that from our algebra class? Oh, she can't talk. Mr. Huth, you remember that? Oh, he went back to sleep. All right, now set up your integration. See, that's why dogs are stupid. You have to yell at them. They're stupid. You should get you a cat, and then you wouldn't have to worry about it. Well, see, there you go. Two stupid dogs. All right, so what will it be? Somebody tell me how you set up your integral. Of x squared dx plus antiderivative of x plus the antiderivative of 2. Oops, I'm sorry. Don't forget to dx. Plus antiderivative of 2 over x minus 1 dx. Finish it out. Doesn't it give you such a sense of accomplishment when you do one of these? You just feel like the king of the world. I'm just kidding. And what do you get? Okay, yes, you get x to the cube over 3 plus x squared over 2 plus 2x plus 2 natural log. Good. I thought I was going to get somebody. Dadgummit. Good for you. Huh? Yeah. I know. I'm sorry. I can't. WebAssign sucks. I think we all agree that WebAssign sucks, especially when you use the MyLab Plus. Okay? And I hate to say this, but why would you suck at this in this section? I just want to hear y'all say it. You suck it out. 90% of these problems are algebra. How we doing, Skype people? Y'all good? I'll make sure they're kind of quiet. Oh yeah, I forgot they're asleep. All right, let's do another one. Let's do example 2. Again, before you start the problem, you have to look at it. Look at it and ascertain, are you going to use this or are you going to use this? All right, go to it. Dang old factoring rules. Dang old. Algebra. Dang old. Algebra 1. Did you cover this in pre-calculus? Do you have pre-calculus, Mr. Edwards?
The non-linear or?
No, the partial fractions. So you remember the partial fractions from algebra, just not with integration.
Yeah.
And where do you go to school? Dang. I didn't think Westside taught stuff like that.
I didn't remember it very well. I just remember it. Didn't see anything.
Who'd you have, Miss Cook?
Miss
Miss Smith? She changed her name or got married again. Huh?
Miss Foster. Miss Foster.
I've heard of her. I just don't know her. Is that the one with blonde? Does she have blonde hair?
I think maybe.
I think she was in a graduate course with me. I'm sorry, Clemson. Mr. Huth, tell everybody how to do this one. I'll get Annabelle to tell you how to do it, but she just got her Candy 1000 this morning. Anybody want to suggest how we're going to do it? Are we going to do long division or are we going to do partial fractions? Why? You can't divide it. That'll depend on that reverse FOIL after you FOCT. Don't pronounce it. When I was in algebra, I would say first rule of factoring, and then I thought about it and I said, you shouldn't say that. And then I said, I'll change it, and I changed it to, and I said, well, that one's much better. So I just started saying FOCT. So, if we factored out a common term on the bottom, we would get x squared plus 2x minus 1 over x, and then we'd have 2x squared plus 3x minus 2. So now we're going to use our reverse FOIL. 1x and 2x. And we got to get a 2 here and a 3 here, so that means the 4 has to come into play. So 2 times 2. And we need a positive 3. You ever have one of those moments where you can't get a word out? 3, right there. So that means the 4 has to be what? Positive. This is unlike, so that has to be negative. So there is your setup. So I'm going to take that setup and we're going to go ahead and set it up. So x squared plus 2x minus 1 over x times x plus 2 times 2x minus 1 is equal to a over x plus b over x plus 2 plus c over 2x minus 1. All right, now work out your partial fractions if you haven't done so. What are y'all talking about? Oh, Annabelle's got her voice. Hey, Annabelle. Nope, she's not talking. She's mad at me.
Better watch out, Hubert.
Ooh, she got an echo going on. Y'all hear that? Well, she'll call me a bad name. She's real bad about that. Annabelle, do you remember how to do long division from algebra? Okay.
Yes, I do.
What is up with that? Huh? Oh, okay. Okay. Okay, so now we get x squared plus 2x minus 1 is equal to what? A times what? X plus 2 times 2x minus 1 plus b times x times 2x minus 1. Y'all make sure I don't make a mistake. Plus c times x plus 2. X squared plus 2x minus 1 is equal to a times, of course that's our, what do we start with? 2x squared plus 3x minus 2. 2x squared plus 3x minus 2 plus b times 2x squared minus 2 plus c times x squared plus 2x. Check my algebra. I'll make this smaller. Faith, I think you got some feedback going on there. You might want to turn down your volume on one of your devices. Just saying.
The b portion should be 2 squared minus x, right?
Did y'all understand that? Say it one more time, Mr. Huth. I got to hold on. Let me turn the volume up a little bit. Hold on. Okay, say it again.
Well now, let's see. The b portion, shouldn't it be 2x squared minus x?
You're right. Thank you. Thank you. Thank you for
You're
paying
welcome.
attention, Mr. Huth. Appreciate it. Everybody else, we need to see it. Oh, yeah, I saw it. I saw it. How's that? All right, now x squared plus 2x minus 1 is equal to 2ax squared plus 3ax minus 2a plus, I'm just looking right quick to see. You could actually, if you wanted to, you could actually do the zero factor. I don't ever think about the zero factor. I should, but I don't. 2bx squared minus bx plus cx squared plus 2cx. Yeah, you could do a -2, and you could do x is equal to -2, x is equal to 0, and x is equal to what? 1/2. Write those three down. I'll put right here. Y'all check me. X is equal to -2, x is equal to 0, and x is equal to 1/2. Would that give you zeros? Yes, Hubert. Thank you, class. So x squared plus 2x minus 1. Get all your x squareds together. So I'm just going to do it because there's a couple of people that wasn't here. So I'm going to just go through the long way and do it because I'm a caring teacher. Any other plus cx squared. I'm having problems now. I hope I'm not fixing to pass out or something. Okay, now our x terms. Minus 2a. This sheet, you see any problems? I'm usually pretty good on keeping you on task. Or you asleep today. 2a plus 2b plus c x squared plus 3a minus b plus 2c x minus 2a. Okay, so now I'm going to take my handy dandy highlighter and using the equivalent coefficients, that 1 right there is equal to what? That. This 2 right here is equal to that. And this 1, -1, is equal to what? That. I'm going to make it a little bit smaller so we can keep going. Because we're going to have to, looks like we're going to have to use what? What are we going to have to use? Solving what? So, which one is the least complicated? The light blue one. The light blue one. So, that's cute. -1 is equal to -2a, and a is equal to what? 1/2. So write that down, and now you can take that a is equal to 1/2 and do what? Plug it in. So now, I'm going to just go ahead and write 1 is equal to 2a plus 2b plus c, and 2 is equal to 3a minus b plus 2c. Now, if you can't see what I just did, I took my light yellow and I took my light green and put them right there. Now, plug in that 1/2. Plug in that 1/2. And now we get, well, that cancels out to be what, 1? And then bring this over, what do you get, 0? 0 is equal to 2b plus c. And this is 3/2. Bring 3/2 over, that'd be minus 3/2. I'm thinking 4/2 minus 3/2 is 1/2, right? Somebody check me. So that'd be 1/2 is equal to negative b plus 2c. Now we got solving systems of equations. I'm going to use the elimination method, and I'm going to multiply the bottom by what? If I multiply it by 0, it'll take the whole thing out. Yeah, let's just multiply it by 0.
Yeah.
Get rid of the whole thing. We took the light green and the light yellow and brought it down. What am I going to multiply this by?
2.
Did y'all understand that? Mr. Hunt, I don't know where you got your microphone, but whoo, all we heard, it sounded like a cat. Man, that's what it sounded like.
My mic is on my laptop, which is on a docking station.
Say again?
My laptop is on a docking station.
Hold on a minute.
Anyways, it's 2.
This glorified speaker, this $10,000 speaker that they probably paid for, ain't even on. It cuts itself off. All right, now speak.
2.
There we go. Now we got it. Yes, we're going to multiply this by 2 so we can get rid of the b term. So I'm just going to rewrite this. Of course, I'll have to. That becomes a 2. And this becomes a negative 2.
The what?
Oh, sorry. This. Okay. And 2 times 2 is 4. So 0 plus 1 is 1. The b's cancel. And c plus 4c is 5c. And c is equal to 1/5. All right, now you got A and C. Now you can find it 2 different ways. I'm just going to plug it in right here and find B. That's okay with y'all. Yeah, that's fine here. 0 is equal to 2 times B plus 1/5 minus 1/5, right, equals 2b. Divide by 2 over 1, divide by 2 over 1, multiply by 1/2, and you get what, negative 1/10? then I'm gonna check one of my, well, we can check all of them if you want to. So everybody write that A, B, and C down, and then go up here, for those that wasn't here the other day. I'm gonna check one of them. I'm gonna check this X is equal to 0. Why am I gonna check that X is equal to 0? Because it'll take out two terms, and that'll leave you with just this right here. So, I hate this check. 0 plus 0 minus 1. This is going to be a check. 0 plus 0 minus 1, so I'm going to get negative 1 is equal to, and I'm just going to use that A term because the B and the C cancels out. So that's going to be A times 2 times 1. So no, negative 1, right? So it'd be negative 2A. Is that what I got? Yes or no, people? Divide by negative 2, divide by negative 2. A is equal to what? So at least I know that I'm on the right track because I got 1/2 using both methods. And that's something you might always want to do just to see. Now, of course, B and C could be wrong, but at least you know you're on the right track with A. So now that we know A, B, and C, we set up our integral 1/2 over x dx plus, what's B? B is 1/5 over x plus 2 plus or minus yeah, training. Minus C is 1/10 over 2x minus 1 dx. Oh, of course. All right, so that'd be a minus, that'd be a 1/5, that'd be a plus 1/5 here. I'm sorry, y'all, the eraser is, somehow it changed, and this is negative 1/10. There. So I'm going to erase this. I'm going to pull the coefficients out, of course. So 1/2 integral of dx over x minus 1/10 dx over x plus 2 plus 1/5 dx over 2x minus 1 and that's going to be 1/2 natural log of x minus 1/10 natural log of x plus 2. Careful here, what is the derivative of 2x? 2 dx, that means you got to put a 2 here, which means a 1/2 out front, so that's going to be what? Y'all check me. Natural log of 2x minus 1 plus 6. Question, gripe, complaint. What did you say?
I need to go down and check that 2X.
Did I mess up? Oh, that'd be 2/5. No. Okay. What is the derivative? Hold on. U is equal to 2x minus 1. What's du? 2 what? 3x. I hate to tell y'all, but that's y'all's first rule of integration. So you don't forget. Huh? Yeah, man. Does that help you? Whoever asked, did you ask it? Whoever asked it? Okay. Feel good? Feel accomplished? How we doing, Skype people? We doing okay? Those of you that are still awake? I'm sorry, what? Okay. Well, I'll give you another one. How about that? There you go. You spoke too soon. Yeah, I'd probably quit if I was y'all. This is one of those where you just don't want to do it. I'll tell you, out of all the sections that we've done so far, this one is the really one. This one is the real. This section really stresses the importance of your algebra, because honestly, how much of one line? I think you do one line of calculus, and that is the line where you do the natural log. That's it. Get the roll while y'all are doing what y'all are doing. Well, it's about the end of the month because I'm broke as Joe Turkey. I'm ready for payday. I was going to have to sell a steer this weekend just to go to the dang old grocery store. Let's see. All right, Ahmed Skyped in. Faith Skyped in. Bradshaw Skyped in. Edwards is here. Grant is here. Huss Skyped in. Khalil Skyped in. Nabay is here. Patel is here. Pierre is not here. Scobie Skyped in. Sheik is here. Silver, you here? I think he's here. Skyped in. I think he did. Thompson Skyped in. Tucker is not here. Unless, I don't think she's... Miss Tucker, you didn't Skype in, did you? I think she did. Wizenhunt didn't Skype in, and Williams is Skyping.
Tucker Skyped in.
Okay, Tucker is here.
Yep.
Well, she didn't speak up. Okay. So the only ones missing, I thought the only one missing was Pierre and Wizenhunt. They're gonna fail. Okay, Mr. Hutt, did you get the answer?
No.
No. All right, what are we going to use? Long division. So x to the third minus x squared minus x plus 1, nothing missing there. 3, 2, 1, 0, nothing missing. X to the fourth plus 0x cubed minus 2x squared plus 4x plus 1. Maybe somebody's going to look at that circle for a minute. And how many times will x cubed go into x to the fourth? X to the first time, Hubert. That's right, class. X to the first times x to the third is x to the fourth. X to the first, or 1 times 1, negative 1 is negative 1x. 1 plus 2 is 3. X times negative x is negative x what? Squared. That's 1. And then 1x to the 0. No, 1x to the first. And then, what do we always do? You always subtract, and that will make this a negative, make this a positive, make this a positive, and make this a what? A negative. And that first one always cancels. And that'll be x to the third. Negative 2 plus 1 is what? Negative 1x squared. And then 4 minus 1 is 3x. And then 1 comes down to help out. I'm sorry, what? Not a nested problem. Well, you're going to have to probably do partial fractions with the remainder, I think. Now, how many times will x cubed go into x cubed? 1 times x cubed is x cubed. 1 times negative 1 is negative 1x squared. 1 times negative 1 x is negative 1x. And 1 times 1 is 1. You always subtract, make sure I didn't make a mistake. Then that term goes out, this turns into a positive, this turns into a positive, that turns into a negative. Then you're left with, that cancels out, right? And 3x plus 1x is what? Oh, yeah, 3x plus 1x is 4x. Check to make sure I didn't make a mistake. All right, now let me take this and shrink it a little bit. So our answer is x plus 1 with a remainder of 4x over x cubed minus x minus x cubed minus x squared minus x plus 1. Y'all check this. Okay, now we got a 4-term polynomial. What do you do with a 4-term polynomial? You factor it. So I'm just going to concentrate on this right here. So we're going to pull this over here. And 4x over x cubed minus x squared minus x plus 1, group the first two, and group what? The last two. What's in common with the first two? Pick the lowest exponent, x squared. And that leaves you with x minus what? Pull out a negative 1, and that leaves you with what? These two match, they're supposed to match. And you get x squared, bring this one and this one down, this is the algebra review, times x minus 1. And now this is your denominator. So now we got 4x over x plus 1, x minus 1, x minus 1. Uh-oh, we got repeating 4x over x plus 1 times x minus 1 what? Now we got a repeater, so that means we've got to do a over x plus 1 plus b over x minus 1 to the first power plus c over x minus 1 to the what? Second power. Well, anybody got any questions so far? So 4x is equal to a times x minus 1 is what? Well, what's missing from this guy? The x minus 1 what? Squared. Plus b times, what's missing here? Well, x plus 1 and another x minus 1. Plus c, and what's missing here? Just the x plus 1. What'd you say, Ms. Sheets? And just go back to your pre-algebra. The common denominator is x squared. See what I'm saying? So, what's missing here? The x squared. All right, looks like you can do the zero property here. So, what can I pick? Positive 1 and what? Negative 1. So, plug in positive 1 and let's see, how can I do this? If I plug in positive, you're just going to have to mentally do it because I don't want to write it. I don't want to put a bunch of marks up here. But if I plug in a positive 1, this term's going to go out and what? So you're going to be left with c. So x is equal to positive 1. 4 times 1 is equal to c times what? 1 plus 1 is 2. So c is equal to what? 2. All right, you do negative 1. Negative 1 will take out the c term and take out the b term, and that'll leave you with what? 4 times negative 1, x is equal to negative 1. So 4 times negative 1 is negative 4. And then what will negative 1 give us here? A negative 2. Negative 2 squared is what? 4, so that's 4a. A is equal to what? Negative 1. And now you can plug it in to get trying to figure out how to get and having a brain baby. Yeah.
Yeah, but we're still gonna have to go through and do the algebra for B, because I don't think you can get B by substituting, back substituting. So that's gonna be, I'm trying to think of an easier way. That's what I get for picking the problem I hadn't done. 4x. Okay, I'm gonna do the, so that's gonna be 4x is equal to, that's gonna be x squared minus 1, so that's gonna be a x squared minus a, right? Plus, that's gonna be, no, that's not gonna be, right? That's gonna be trinomial. So that's going to be a x squared minus 2ax, y'all check me, minus a plus bx squared minus b plus cx plus 1 and 4x is equal to, and I'm going to pull out my a squared, that's going to be a plus b x squared minus 2a plus c x, right? Minus a minus b plus 1, minus a minus b plus 1. Yes, thank you. And what? Okay, thank you. And that's going to be positive. Thank you. Well, 4 is equal to negative 2a plus c, right? I'm just seeing how we can get, we need b, so that's not going to help us. So where, right here? Oh, well, b is equal to 2a. Yeah. I didn't think about that. You're right. You could do a plus b is equal to 0. Where? Are you talking about right here? Okay. No, I don't think that would work because it's in the middle of this. You didn't do it over here. It's in the middle of this because this is not equal to 0. It's equal to 4x. So you got to make x equal to something. Hold on, just give me a second. You may have to use 0. 0 is equal to a plus b x squared. That's not yeah, 0 x squared plus 4x. Yeah. Yeah, you can say x squared is equal to 0, and a plus b is equal to 0, and a is equal to negative b, or b is equal to negative a. Well, that would work or not. Yeah, so that'd be a positive 1. Let me see if b is equal to positive 1. Because I haven't done the problem. Yep, that's right. That's right. So, now don't forget what we found. What did we find? B. B is equal to 1. So now, you do, I'm not going to put this on the test. That's going to be, I don't forget, negative 1 over x plus 1, right? Plus 1 over x minus 1 plus 2 over x minus 1 quantity squared, right? Now what was the first two? X plus 1 right there. So we've got the antiderivative of x dx plus the antiderivative of 1 dx plus antiderivative of negative 1 over x plus 1 dx, which that negative can come out here. Plus, I lost my place, plus 1 over x minus 1 dx plus 2 over x minus 1 quantity squared dx. All right, now find your antiderivatives there. Hold on a minute, I'll tell you. I gotta do it. Let's see. It's gonna make it. Oh my gosh. You gotta do it again. You gotta factor that x minus 1 into x plus, no. Yeah. X minus 1 and x minus 1. Well, no. Be x minus 1 and x minus 1, yeah. You gotta do it again. What, this one? This, no, you can. Hold on. I haven't looked, but you can bring this up. No, chain rule would be, that'd be, no, yeah. If u is equal to x minus 1, then du is equal to 1 dx. Let me see what that is, because I don't know if you can use a chain rule there or not. Where is the, I don't even see it. I'm not good at the blue letters. Looks like to me they use a chain rule. course, I can't think with all this stuff. Y'all got all this, haven't you? I've gotta erase some stuff. I can't think. I can't think anyway, much less when it's all scattered. Okay, let me do it, and we'll get, quit jumping the horses. Shoot, we gotta do it first. That's all right. All right, the first one, the antiderivative of x is what? 1/2 x squared, right? And then plus x minus the natural log of x plus 1 plus the natural log of x plus 1, which that does what? That cancels out. We don't have to worry about it. Huh? Oh, it's minus 1. Minus 1. I'm going to put this separate. Plus the anti-2 dx over x minus 1 quantity squared. Well, what is the derivative of x? Dx. No, hold on. For some reason, let me do this. Plus 2 antiderivative of x minus 1 to the negative 2 dx. U to the negative 2 du, which is equal to, that would be u to the negative 1, right? U to the negative 1 over what? Negative 1. Bring that down. That negative 1 is not going to change anything. So it looks like to me you get negative 2 over u, which would be negative 2 over what? X minus 1? And that's what they got. Hold on, let me see what they got. Negative 2 over x minus 1. Yep. This is what they've got, and you tell me if that's what I've got. They've got x squared over 2 plus x plus the natural log of x minus 1 minus the natural log of x plus 1 minus 2 over x minus 1. Remember, well, I've got the negative 2 over x minus 1 right there. And addition is commutative, so they can be interchanged. How are we doing, Skype people?
Good.
Okay. 5 absences. What are you talking about? Okay. That one probably will not be on the test. I know. I can just give you one problem. All right, I'm going to give y'all one that you can work on at home because I don't think we have enough time. We can try it, but let's see if I got it in here. I think I do. Yeah. 2x squared minus x plus 4 over x cubed plus 4x. We'll try to get as far as we can go because class is over at 10 o'clock. We got 9 minutes. I just want to make sure you have 4 good problems to go by to do your homework and test or whatever. Why, you don't want to do it? You want me to call class off? You can just quit. I can't believe we got it right. Y'all are smart. That's why. I'm about ready to go home and go to bed. I couldn't go to sleep last night. Jack Daniels didn't work. No, I'm just kidding. That's like I'm an alcoholic. Really, I think. My daughter, she comes to my house and tries to go to the house. Hey, all this stuff has been in here for years. Why don't you throw it away? I said, well, you never know who's going to come over. That's the way my liquor cabinet is too. But that's the good thing about alcohol. It don't go bad. At least you know you don't have to do long division, right? I can put a lot of long divisions on there if y'all want me to. Y'all usually hate that. Two x squared minus x plus 4 over x times x squared what? Plus 4 Hubert. That's right, class. Okay, that's it. So you got to use your quadratic type. So you got to use ax plus b or bx plus c or whatever, because what's wrong with x squared plus 4? You can't factor. You could put cannot do it. That's what you can just put on the test and put a circle around. Find x. Here it is. So, here we go with the algebra. 2x squared minus x plus 4 over x times x squared plus 4 is equal to a over x plus bx plus c over x squared plus 4. 2x squared minus x plus 4 is equal to a times x squared plus 4 plus bx plus c times x. Alright, do your algebra. Remember this one in before it's over with. Two x squared minus x plus 4 is equal to ax squared plus 4x plus bx squared plus cx. Oh yeah. Huh? Oh. So 2x squared minus x plus 4 is equal to a plus b x squared plus cx plus 4a. And let's see, equivalent what? Equivalent coefficients. This yellow, this light blue one, as this sheet says, is equal to that. that 1 is equal to that. And that 4 is equal to that. All right, finish it out. Is it raining? That's good. My pasture's needed. So, what is everything equal to? Well, one good thing is C is equal to what? C is equal to -1. A is equal to what? A is equal to 1, right? And now you can take A and plug it in for, let's see, A plus B is equal to 2. 1 plus B is equal to 2. B is equal to 1. Y'all check me. Huh? Okay. And now you just plug and chug. Antiderivative of A over X dx plus the antiderivative of X plus X minus 1, check me. X minus 1 over X squared plus 4. Yes or no? Looks like, yep. And you can break that second one. Antiderivative of 1 over X dx plus antiderivative of X over X squared plus 4 dx plus the antiderivative of minus 1 over X squared plus 4 dx. That's the same denominator. You can break that up into two denominators, yes. Now you should be able to finish it. Now I'll tell you right now that last one is going to be the inverse tangent. I'll just go ahead and tell you that. Because remember, you recognize the X squared plus 4? And the reason you have to use the tangent is because right here, U is equal to X squared plus 4. du is equal to what? 2x what? dx. So you put a 2 here and a 1/2 here. You can integrate this one. But that one, you're going to have to go to trig substitution. Okay? The reason I'm showing you this one is not because of the trig substitution. I'm showing it just a different type of problem, as I told you the other day. Well, you got to go back to the hold on a minute. Where's trig substitution? It's 7.3. Yeah, there it is. Go back to page. Oh wait, you don't have the book, but on page 478. Let me finish that Tuesday, okay? Let's finish that Tuesday. I don't want to end on a bad note, but we'll finish that Tuesday. All right, y'all get out of here. Have a good weekend. Skype people, if you got any questions, we'll go over them on homework, on your grading. And the rest of y'all have a good weekend. Work on that homework. I'll probably put the test up next week. Now I'm gonna finish that problem. Probably Monday when I put it, or Tuesday, whatever day's next. Tuesday for y'all. All right, let's look at that homework. Let me shut the vigilator off. Skype people with